Mindsetters, I'm Megan. Welcome to today's Grade 10's Math Show. Today we have a special revision lesson on algebraic expressions and exponents prepared for you. We'll be selecting highlights from the lessons shown early in the term to help you revise for your end of term tests. You can download the notes for today's show on learnextra.co.za/live.
Quickly going to fly through the rest of distributive law, binomial by binomial, monomial by binomial, and a binomial by trinomial. Hopefully you guys remember what all those binomials, monomials, and trinomials means, but we'll remind you now. And guys, what I'm going to do with these is you'll see there's two parts to the questions. There's A and B, and I'm simply going to do either the A part or the B part, and it's going to be up to you to do the other one. Okay, in this example, when they say simplify the following expressions by expanding, I'm going to look at B, simply because we haven't done an example with the number behind the brackets. Okay, we've always done them so far with the number in front, so let's look at what happens when the number is behind the bracket or behind the binomial. So here we're looking at a binomial, two terms, by a monomial, one term. Okay, so remember the rule stays exactly the same whether the number's in front or the number's behind the bracket. We're going to times the number by every term inside the brackets. Okay. So, and I'm going to fly through this because I think a lot of you guys have the gist of it now. Minus 6 times positive 2. Remember to multiply your signs first. A minus times a plus will give us a minus, and 6 times 2 is 12. All right. Then we're going to multiply the negative 6 by the negative 5p, multiplying your signs first. Minus times a minus is a plus. 6 times 5 is, whoopsie, that pen is going a bit wonky, and it was behaving for the first time. So minus times a minus is a plus. 6 times 5 is 30. 6 times 5p is 30p. All right, so as I said, guys, flying through these because I can see from the page and the comments that you guys really understand this section. Okay, so for the next one, we are multiplying a binomial by a binomial, so that means two terms by two terms, all right? I'm going to do the A part, and you guys can try the B parts at home. Okay, so we've got 2x minus 2 times 3x plus 8. Now, a lot of you guys would have learned to multiply this, not just by distributing each term, but you would have learned something called FOIL. Okay, and what FOIL tells you is the order in which you should multiply each of the terms. So first, outers, inners, last. Okay, and sometimes it's called the Kitty method and all sorts of other names, but remember your basic concept that you're using here is distributive law. You're multiplying every term in the first bracket by every term in the second bracket. Okay, so I'm going to multiply every term in the first bracket by every term in the second bracket. Okay, so let's have a look if we do that. So I've got 2x, positive 2x times positive 3x. 2 times 3 is going to give me 6. X times x is x squared, because remember we use our rule for exponents and we add the powers. All right, then we're going to multiply 2x by 3x. Oopsie, sorry guys, I just did that. 2x times 2x is going to give me 6x squared minus 2 times positive 8. Remember to multiply your signs. A minus times a plus is a negative. 2 times 8 is 16. And then we're going to times 2x by 8, and we're going to get 2 times 8, positive 2 times positive 8 is 16, and x times 1 is just x. And then lastly, minus 2 times positive 3x, a minus times a plus is a minus, 2 times 3 is 6, and x times 1 is just x. Now remember, when you get to this point, you need to look at your question and see, do we have like terms? Yes, we do. So we add the like terms. So I'm going to get 6x squared plus 16x minus 6x is plus 10x. And minus 16 will just bring down because there are no other terms to add that to. All right. Okay, so I hope you guys are all following and you're breezing through that section, which I think you will be doing. And Indy, do we have any questions?
Oh, I don't have any questions. I just want to say one more thing. I'm just so excited to be back here on air. This is our first show, Mindsetters, for the year, grade 10s, and it's especially for you. And I know that there are a whole bunch of you are tuning in not only on Facebook, facebook.com/learnextra, and on Twitter, but you are really, I can't believe how many guys are actually tuning in. I've got Sasanda who says she cannot wait for the grade 11 lesson. We've got, let me have a look here. Tendi says she's loving the lessons and she's really enjoying it. And there are no questions so far, but guys, let us know how your school year has gone. And even though that this is the first show of the year, we want to know how things have been going so far. So post that onto our page. And what I'm going to do is I'm going to send it straight back to Natasha.
All right. Okay, guys, so we're really going through this quite quickly now because a lot of you understand your basic concepts. We're now going to look at multiplying a trinomial by a binomial. So remember, that's 3 terms by 2 terms. I'm going to have a look at A, and you guys can try B at home. All right. So remember, the concept is exactly the same. You're multiplying every term in the one bracket by every term in the other bracket. So we're going to go from the binomial, we're going to times. It doesn't really matter. I mean, if you wanted to, you could start with every term in the first bracket. I prefer to times the smaller bracket out. So I'll distribute from the smaller bracket, but it really doesn't matter because remember, we use the associative law, so it doesn't matter which order you do it in. But I'm going to say 5y times every term in the first bracket, and then minus 12 times every term in the first bracket. And we're going to go through it quickly. So if I say positive 5y times minus 2y squared, I'm going to get positive times a minus is negative. 5 times 2 is 10. We've got y squared times y. So the only thing that could trick you up here a little bit is your exponents. Remember, when there's no power written, the power is always 1. So if I say y to the power of 1 times y squared, keep your base, add your powers. So y squared times y to the power of 1, 2 plus 1 is 3. Okay, so I'm going to get minus 10y cubed as my first term. Then I'm going to say positive 5y times negative 4y plus times a minus is minus 5 times 4 is 20. And y times y is y squared, again using your laws for exponents. And then we're going to go positive 5y times positive 11. Positive times a positive is a positive. 5 times 11 is 55. And y times 1 is just y. Okay, so those are the terms we get from just the 5y being multiplied into the bracket. Now we need to multiply the negative 12 into the bracket. Okay, so let's have a look. A negative 12 times negative 2y squared. Remember to multiply your signs. Minus times a minus is a plus. 12 times 2 is 24. And y squared. So y squared times 1 is just y squared. Minus times a minus is a plus. 12 times 4 is 48. Y times 1 is just y. And then minus 12 times positive 11. Now, I do think I can do this in my head, but I'm going to double check on my calculator. Plus times a minus is a minus, and I think your answer is 132. But let's have a quick look, because we don't want to get things wrong so early in the year. 12 times 11, 132. Okay, so we're safe. All right, so that is the multiplication of the brackets all done. Multiply the trinomial by the binomial. We get this expression. Remember, when you get to this point, you're not done. You still need to add your like terms. So you look at your expression, see what like terms you have. You can see that you've got 2 terms in y squared, and you've got 2 terms in y. So the minus 10y cubed and the negative 132 are simply going to be brought down, but you need to add your like terms. Okay, so that one and that one, and minus 20y squared and positive 24y squared. So minus 20y squared plus 24y squared will give me positive 4y squared. And then positive 48y plus 55y. Okay, let's do that on our calculator. So we've got 48 plus 55. And we get 103. Okay, so 103y as our third term. Okay, guys, so that's the answer to your simplifying of a binomial times a trinomial.
Let's go to a short break now. Remember, if you are struggling and you need help, remember to post your comments and questions on our Facebook page, facebook.com/LearnExtra, or on Twitter @LearnExtra. Don't go away. We'll be right back. Welcome back, guys. Let's get into some more revision. Over to you.
Now let's go and tackle some questions that deal with that, with revising those four, actually five, if you want to call the sum and difference of cubes into two different ones. But really it's the four basic units or the tools that we use to factorize. First rule is always to analyze and to ask yourself, have I got a common factor? And if I do, then I'm going to remove that common factor. And remember that to take out a common factor, to remove a common factor, simply is the inverse of what I was doing if I'd multiply by using the distributive law. So I would be dividing by that factor. And then mentally, you should be multiplying back to see if you'd get back to the original. So we've got, first question is to factorize this expression. And I would always ask that you would analyze and talk to yourself in terms of what you're seeing. I'm seeing a polynomial. There are 4 terms. And my job, when I see the word factorize, is to get the expression into one term. So my whole job is to find one term out of those 4. And before we jump in, it's not a trinomial, it's not the difference of squares because I've got 4 terms. So therefore has to be, and there's no cubes there, so it has to be a common factor that exists there. So if we look at it carefully, out of the 4, we notice that this x squared and this term here, they both have got an x in them. And we also notice that this one and that one have got an a in them. So we're going to factorize by grouping, by taking out the x, and we are left with, what are we left with? If you take out x, what you're saying is x squared divided by x gives me x, and negative 2x divided by x gives me negative 2. Now, young grade 10s, you are budding mathematicians. You cannot just, mathematics isn't done just one direction, one route. You need to always verify that what you're doing is in fact correct. So accuracy is paramount. And in order to check our work, if we've just divided, we can now check by multiplying. So if we tested x times x, we do get x squared, and x times negative 2 is negative 2x. And factorizing is one of those topics in maths that you can check your work. You can verify your accuracy by just going to check that what you've done is actually correct. You don't have to wait for somebody to tell you whether you're right or not. You know by your checking mechanisms that it's correct. So it's basically almost like an accounting tool that you can have, like a balance or a journal that you can actually check. These things balance, they match, they make sense to me. With the yellows, what is that's a common factor? Would you say that the common factor is a, and then I'm left with minus x plus 2? Would you say that that's correct? Okay, no, that is not correct, because these 4 terms don't give me one term. I've now got that as one term. What I've done is I've isolated the 2 blue terms to give me one term, and I'm getting those 2 into one term. So there is a missing sign over here. Okay? And in mathematics, very often, you're trying to say something, and you'll write statements like this, and then you won't go anywhere because there's a breakdown. So if I have 4 terms, you've broken it into 2, I have to see a sign that separates those 2. It's not a times sign that separates these two. It's actually a positive sign. So I could take this out as an A, but then I have to have a plus A. I've taken out a plus A. So I've got a plus A that I've taken out. What does it mean? Divide by A. So negative AX divided by A gives me X, actually minus X. And 2A divided by A gives me 2. Okay. Now, if you take out that positive A, you get left with this yellow bracket, which in terms of variable and number look identical, except for a sign. So if you look at this one, that's a negative X, that's a positive X, that's a positive 2, that's a negative 2. In mathematics, when two brackets have the same variable and same numbers, but they are different in terms of signs, we know we can take out a common sign. So therefore, we can say that if I have an X times an X minus 2, and I take out a negative 1 as a common factor, then I've got an X minus 2. In that way, I've now made, let's use this one. I've got this X minus 2 as now a common factor. So factors can be numbers, variables, and brackets. They can operate in 3 different ways. So if I take out this X minus 2, and that becomes our common factor, X minus 2 as a common factor, I'm now left with what? Out came the X minus 2, so I'm dividing by X minus 2 goes in there once, I'm left with X, and I've taken out the X minus 2, I'm dividing by X minus 2, so I'm left with A. Right, so that's my common factor. Then we can factorize a trinomial, but I'm going to make it easier for myself, and I'm going to say, hang on, I can see that 3 is a common factor. So if I take out 3, I'm left with 2x squared minus 5x minus 3. And that trinomial now can go into 2 brackets. The first term is 2x times x. The last term is 3, so 3 and 1. And if you look at your inners and your outers, I'm getting a 3 and a 2. And that's not going to give me 5. So I need to just edit that slightly and say that doesn't work, because I need to get a 3 and a 1. So now I've got negative 6, and I've got positive 1. So I've now got the factors. And if I check, negative 6 plus 1 is negative 5, and 1 times negative 3 is negative 3. Can you see how you can verify your work and you can check it out?
Let's go to a short break now. Remember, if you are struggling and you need help, remember to post your comments and questions on our Facebook page, facebook.com/LearnExtra, or on Twitter @LearnExtra. Don't go away. We'll be right back. Welcome back, guys. Let's get into some more revision. Over to you.
When you were in primary school, you learned about 4 operations: addition, subtraction, multiplication, division. And here we are in grade 10, and we're still working with the same 4 operations. Well, nothing changes, except the way the numerators and denominators look. They kind of get quite big and large, and at times they look monstrous. But remember what I said earlier, the principle that you learned way back in primary school still remains the same. So, how many of you remember how you would add halves and fifths? Do you remember that? If I had a fraction with halves and I had a fraction with fifths, what did you do? Well, that's when some of you began to learn the language of lowest common denominator, which really just meant that you looked at your multiples of 2, you looked at your multiples of 5, and you said, which number is common to both? And you said 10 is common to both. And then if you go on, you would find that 20 is also common to both. And then you would go along and find that 40 is also common to both, or even 30 is common to both. So between the multiples of 2 and 5, you have many options of a common number that both 2 and 5 can go into. And in order to add fractions, we don't want to go far down the list and find that special number. We want to work with the smallest one because it will reduce the arithmetic that we're working with. So, if we look at 2 and 5, what would be what we call the lowest common multiple? Now, because we're working with fractions, we are looking at the lowest common multiple of those two denominators. And that's why we call it the LCD. It's just the lowest common denominator between two fractions. But we're not really looking at the denominators alone. We're actually looking at the common multiples that those two numbers have got. And so I'm going to work with a fraction that works with halves and fifths to start off with. Let's have a look. Okay, so we're going to go straight on to the example. Here we've got a classic example of, we've got halves, x over 2, we've got fifths, x over 5, and then we've got that constant 3. Now, if you remember 3 as a whole number, 3 is actually 3 over 1. So we really are still adding in halves and fifths because we've got the other one as 1. And whatever we choose from the halves and fifths will also work with a denominator of 1. Right, so we've already spoken about what is the common multiple between 2 and 5. When we go down the list, 2, 4, 6, 8, 10, we've got 5, 10. So 10 is the number that both 2 and 5 can go into. And so we say that we can now write, let's see. All right, before we do that, it's 3 wholes, we've spoken about that, is that we'd like to write each of these fractions, x over 2, we'd like to write it as something over 10. We'd like to write the fifths as something over 10. And we'd like to write the whole as something over 10. Okay, so what must we do to halves to get it to tenths? We must multiply it by 5. But we say that whatever we multiply the denominator by, we also multiply by the numerator, because a number divided by itself is 1. And when you multiply something by 1, it doesn't change its value. So when we say we multiply both denominator and numerator by the same value, in essence, what we're doing is multiplying by 1. So we're not changing anything. So it's a very clever tool to help us to not change the value. Fifths, how do I get fifths to tenths? I would multiply by 2 numerator, denominator. And wholes, how do I get them to tenths? I would multiply by 10, both numerator and denominator. So that's what's going to happen in our next step. We would get, just take this out, there we go. And let's just select there we go. Okay, so we're saying, how do I get my halves to tenths? Multiply by 5 divided by 5, which is my 1. How do I get fifths to tenths? Multiply by 2, numerator, denominator. How do I get ones to 10? Multiply numerator and denominator by 1. So I've got this 1, 1, 1, and I'm not changing the amount that I'm starting off with. Right, so if we do that, we now get, we've got x times 5 is 5x over 10, x times 2 is 2x over 10, and 3 times 10 is 10. And our purpose to start off with was that we were getting the same denominator. Why do we do that? Why do we want the same denominator? Well, it's a simple thing, is that if your denominators are different, then the sizes of your fraction are different. And we cannot add unlike sizes. I can't add a half and a quarter together because my half is much bigger than a quarter. So what I'm really doing is I'm saying, how can you write a half? A half is the same as 2 quarters. Now that I've got 2 out of the 4 and I've got 3 out of the 4, I can now add up the quarters. I'm going to get 5 of that size piece of whatever you were working with. So it's very important with fractions that when you're adding and you're subtracting, you need to add in like portions. And what tells us what that portion is that denominator. So if I'm adding in tenths, they are equal sized portions. I only need to work with the numerator now. So my numerator is 5x minus 2x plus 30. So I land up with a fraction out of tenths because now I'm adding in the same kind of portions. And I've now got 3x plus 10. Okay. what happens? So that was a very quick mix of primary school and high school fractions. Same principle, common denominator means the common multiple between the two numbers. If you find a bigger one, is there a problem? No, there's no problem. You can work with any number that's common. But you are going to find yourself creating this bulky arithmetic. And so hence we try and keep things to its simplest form. What's going to happen is you're going to have a common factor later on in your fraction. Okay, so don't get too worried about that common multiple as long as you find one that's common to both numbers. Right, but now what happens when we have variables? How does this work? How do I find the common denominator when I've got variables? Well, the numbers, we always do the same thing. It's a common multiple. The variables, we find the highest power of that variable. That will be our common denominator. It's an easy way to find it. So if we've got x's and x squareds, then it's obvious that x squared is bigger than x, and that x can go into x squared, and x squared can go into x squared. So hence, x squared becomes our common denominator. So we look for the highest power of that denominator. That becomes our denominator. Now, you could say, if I've got x and x squared, why not make it x cubed? Remember, there are an infinite number of common denominators. But for us to have reduced amounts of algebra to work with, we would like to work with the highest power of the given denominators. Right, so let's have a look at our example. We've got 2x squared y, 4x squared y squared, and 6x. Deal with one thing at a time. Let's deal with the coefficients first. So we've got a 2, 4, 6. 2, 4, 6. What is the common multiple between 2, 4, 6? It's not 2, it's not 4, it's not 6. If you are struggling to find it, then you can multiply all the numbers together. So it's 6, 4 is 24 times 2 is 48. So 48 will work. But I would say that if you look at the common multiples of 2, common multiples of 4, common multiples of 6, you'll be pretty sure that when you start off with the highest number, with 6 and 12, what happens with 12 is that 4 has also got 12, and 2 has also got 12. So I think let's work with 12. Can you see how much easier it is to work with 12 than 48? Okay? And then we said every variable, every single variable, or every single bracket that you find has got to have the highest power. So let's look at x. I've got an x squared here, I've got an x there, and I've got an x there. Do you agree that x squared is the highest power? So we will fetch that for our common denominator. And then y squared is also the highest power. So those denominators that I'm going to now have, let's just see. Okay, so I'm going to have this fraction here as something over 12 x squared y squared. I'm going to have this fraction as 12 x squared y squared in the denominator. Okay, we'll get to the next two just now. So we've got, this one's gone from 2 to 12. So what's it missing? It's missing a 6, and it's gone from x squared to x squared, so it's missing nothing over here, and it's missing a y, because that denominator's got a y squared. So I'm going to multiply this denominator and numerator by 6x, no, not x, we don't have any x there, we've got a 6y, that's what it's missing, 6y, 6y. Okay, now as grade 10s, we are really grooming you for grade 12, and you must be able to do some mental arithmetic or some mental algebra as you go along. We don't need to write the 6y over 6y because we are having a look. If you just use your fingers, you go from 2 to 12, so you've got to multiply that by 6, and you're going from y to y squared, so you've got to multiply it by y. And then you can just write the numerator as 6y, because when you get down to the next step, there's my 12x squared y squared, and where am I get 18y from? Because the 6y was missing from the denominator, so it's missing from the numerator as well. So you've got to be able to be flexible, quite flexible with that finding of that denominator and seeing what's missing. Remember that what's missing is what you're going to be multiplying by. So with the 4 and the 12, there's a 3 missing, so 3 5s or 15. There's an x missing, so there's the x, and the y squares are there. With 6 and 12, 2 is missing, so you multiply 7 by 2. and x has only got one x, so there's an x missing, so there he is, and there's a y squared missing. Then 4 is always written as a 1. So this is 4 over 1. So the whole denominator has got to be multiplied by that 4, so it's minus 48 x squared y squared. So same principle. I've got to find the common denominator, and I've got to find what factor I need to multiply each denominator by in order to make it an equivalent fraction. And what I do to the denominator, I also do to the numerator in terms of multiplication. So I can now keep going. Right, so let's just go up a little bit. Okay, so I've now got x y squared. There's no like terms, so that's as far as I can go. I can't keep going any further. Okay, so we've got my common denominator: halves, thirds, and quarters. 12ths will do. So 2 into 12 goes 6 times, so I've got 6x minus 6. 3 into 12 goes 4 times, so I've got 4x minus 8. 4 into 12 goes 3, so I've got minus 3x plus 9. All right, so we now have 6 and 4 is 10. 10 minus 3 is 7. And I've got minus 6 minus 8, or 9, is 1. And that is minus 5 over 12. So when everything is in 12ths, I can now add.
Let's go to a short break now. Remember, if you are struggling and you need help, remember to post your comments and questions on our Facebook page, facebook.com/LearnExtra, or on Twitter @LearnExtra. Don't go away. We'll be right back. Welcome back, guys. Let's get into some more revision. Over to you.
So let's just recap what we did a little while ago. 8 to the power of 2/3 simply means that I have a root of a base 8 squared, and that root is defined by the denominator, which is the cube root. So this always refers to the root of the number, and that always refers to the power of the number. So let us apply that in the next few exponential expressions that we're going to be doing. Right, first one is up here. We've got, let's just read it aloud. We've got the 4th root of x cubed multiplied by the square root of x to the half. So if I want to simplify exponential expressions, I'm not going to simplify them with different roots. I'm going to simplify them with exponential format, because I have the laws of exponents to help me. Remember, you've got laws of exponents, but you don't have laws of surds. So we will often just translate everything into exponential format. It's much easier. You'll find when you get to grade 12 and you're working with calculus, it's exactly the same thing. You want everything in exponential format because we've got the laws of exponents to help us simplify things. Right, so let us try and put this into exponential format. We've got this equals x cubed is my power, and then I've got my 4th root as the root to work with, so therefore my root goes underneath, and I'm multiplying that by x to the half. And what root do I have over here? What is the root that I'm taking? Correct, that's the power of a half. So in the end, I've got an x to the 3/4 multiplied by an x to, remember the rule for a power raised to another power is just a quarter. And then we've got same base, and I'm multiplying same bases. So I get x to the power of 1, because 3/4 and a quarter is just 4 over 4, which is 1. So the value is x. Okay, then I can go on to the next question. Right, so again, let's look at a to the power of m over n. What does that mean? The nth root of a to the m, always the root for the denominator. So if I've now got all these surds over here, I'm going to first of all change it into exponential form. So, everybody out there, let's do this together. We've got a cube root over here. So, we've got an a squared times a b to the minus 6, all to the power of cube root. So, it's to the power of a third. And notice what I'm doing now. I'm writing the product that's underneath the root first, and I'm raising it to the root, which is a third. And I'm multiplying that by, what root have I got here? It's the square root, so it's b to the minus 3, and then it's the square root, so it is over 2, because remember the square root is denominator 2. And then in my denominator, I've got something very interesting. I've got a bracket raised to the minus 1, and then I've got the square root. So I work from the outside in. So I'm going to take the square root, which is going to become to the power of a half, and we then have a squared, which is raised to the power of a third, times b to the minus 1, and then I'm raising it to the minus 1, but I have this square root over here. So there's my square root. So my square root is to the power of a half. Okay? Now, you can write it in two ways. You can write it as the whole power raised to the half, or you can just divide the existing power by 2. It really doesn't matter. It's however you see that it works best. Okay? And then at the same time, I have taken this cube root over here. Already, I've changed this number here into a to the 2, and then it's the cube root, so it's 3 there. Okay, so that number's been changed into its third form. That one stayed, b to the minus 1. It was all raised to the minus 1, there it is, and then we had the square root. So there was a lot of changing from third into exponential format. Why are we doing that? Why are we changing to exponential format? Because we can use the laws of exponents. We have got laws to help us simplify exponential expressions. Right, so we've changed the cube root, we've changed the square root, and we've changed. So we've, in today's technological world, we would say we've reformatted the expression. So it's the same expression, but just in a different form. That's all that's happened to it. Okay, so now let's do some multiplication. We've now got, let's just go up a little bit. Okay. We've now got two bases. Can you see the product? And we're raising it to the power of a half. So each of those is going to be raised to the power of a third. We've then got two bases over here, and each one is going to be raised to the power of negative a half. So let's do that together. A to the 2/3 times b to the minus 2 times b to the negative 3 over 2. We're dividing by a to the power of negative a third and b to the power of a half. Okay, now we've got only base a and base b. We're multiplying, we're dividing, so we're going to group those together. So we're going to get a to the power of 2/3. When we divide the same bases, we subtract our exponents. Multiplied by b, same base, add exponents, so it's minus 7 over 2, and we subtract this one. Okay, so when it's same base and we're multiplying the same bases, we add our exponents, so that's negative 4, negative 3 is negative 7, and we're dividing by b to the half, so we're subtracting that exponent. Right, so now it's a simple exercise of a to the 3 over 3, which is just a, multiplied by b to the negative 4, and if I write this as a positive exponent, then I would get a over b to the 4. Okay, so a lot of work going on there. We first format the third to become an exponent, and then we use our exponential laws. And I would suggest keep your exponential laws next to you all the time so you can verify if I'm multiplying, if I'm dividing. Remember, there are no laws for addition. For addition, you add the terms. There are the algebraic laws for terms, but there are no laws that govern the exponents around terms.
Well, guys, we've come to the end of today's show. Thanks for joining me. Remember to visit our website, learnextra.co.za/live, to get the notes and to watch the videos. And if you are stuck and you have any questions, send an email to helpdesk@learnextra.co.za and we will help you. Also, guys, we are dedicating the month of March to Library Month. Join us as we discuss some great books and some exciting competitions on the way. Goodbye.